Yeah, good evening, everyone. Welcome to the Ignite 3.0 from the VCube Software Solutions and ITM Engineering College Technically. Yesterday, we discussed about Gemini and how to implement Gemini models using LLMs. Today, I will be discussing about RAG with vector databases. Okay, so on Saturday's hackathon, 50 problem statements are prepared. 50 problem statements are prepared. As a student, you should implement Gemini LLM or any LLM with vector databases with RAG. Yeah. So every student has to implement this concept. So with your permission, I will be starting session. Today, I will be discussing why RAG is used to get real-time applications. So I welcome you all for the session. Yeah. So first 2 minutes, I'll discuss about yesterday. I discussed about what is Gemini, what are LLMs, and we also discussed about what are various kinds of Gemini models available. Then how to send a prompt and various kinds of prompts. Then how to get response from LLM. Then configuration parameters with LLM. Configuration parameters with LLM. Then we discussed about what is the use of tokens. Then we discussed about what is context window. Then we discussed with one program how to work with notepad documents, one program how to work with PDF documents. Okay, now this is what we discussed with yesterday's class. In today's class, I will be introducing what is RAG, why RAG, and what is the architecture of RAG. Okay, now. So I welcome you all for the second session on Ignite 3.0 from VCube Software Solutions as well as ITM. So can I go? Yeah. So first of all, I will be discussing what is RAG. Stands for Retrieval Augmented Generation. It is a AI architecture that will be used for three purposes. One is retrieving relevant information from external knowledge bases. I will discuss one by one. What are the external knowledge bases? Okay. The first point is retrieves relevant information from external knowledge bases. Then second one is augments the prompt with relevant documents. And third one uses LLM to generate grounded information and context-aware answers for our queries. Okay. Now, RAG combines two things. One is information retrieval and it also combines LLM. Now, the LLM which I'm using is called as Gemini models. Gemini 2.5 Flash. Yeah. So, first of all, I'll go very slowly. Okay. And let me get into the topic. Actually, RAG is a powerful technique. It is combining two topics. One is retrieval mechanism as well as text generation mechanism with the help of LLMs. Where what kind of LLMs we can use here? You can use Llama, you can use GPT, or you can use any LLM, Gemini, and to answer the questions using our own data and not just what was the trained on by LLM. Now, slowly I will go one by one into that. So with your permission, I will take 1 minute. So first of all, I will discuss about RAG architecture in detail. Then I'll go for in detail implementation of everything. So RAG architecture contains three main components. One is retrieval. Second component is augmentation. Third component is generation. Now, how it will be done, I will discuss one by one. The first one is called as knowledge base, external knowledge base. For that, we will do collection of documents. Collection of documents. This collection of documents may be web documents, web internet documents, or PDF documents in the form of books, notepad documents, notepad. Or sometimes we can also use databases such as JSON or SQL. Yeah, this is the first thing. So in order to generate a RAG architecture, first of all, we should collect knowledge base. Now, later I will discuss about why RAG. The second one, why we should go for RAG, I will discuss. Second one is called as parsing and pre-processing. Yeah. So what is the meaning of parsing and pre-processing? Whatever the data we are collecting, we need to extract text from knowledge base. Yeah. So in order to extract web documents, generally we will use either Beautiful Soap or we will use Selenium. Yeah. So from PDF documents, we'll use PyPDF tool. From Notepad documents, simply we will use File.io. From the JSON or SQL, this is nothing but with the Python tools we can access it. Yeah. Now, once we extract the text from the knowledge base, the third step is called as chunking. Now, this is the most important step, chunking. Now, every LLM has its own context window, Yesterday I discussed about what is context window. Now, they cannot take large amount of data. So we need to divide large documents into small documents. Yeah, each and every step I will discuss practical knowledge within few minutes. Okay, now. And once we divide the large documents into small chunks, this is called as chunking. How chunking will be done, I will discuss in detail in few minutes. Fourth step is called as embedding. What is the meaning of embedding? Machine learning algorithms or deep learning algorithms or any LLM, it cannot understand text. So the text data will be converted into high dimensional numerical vectors. Yeah, this technique is called as embedding. So if you wait for another few minutes, I will discuss in detail what is chunking and what is embedding, what are the tools and transformers which we need. I will discuss one by one. So all these four statements are okay for all of you. The first one is called as knowledge base, where we will take various kinds of web documents, PDF documents, notepad documents, JSON or SQL documents. Second step is called as parsing and pre-processing, where we need to extract the data from the knowledge base. Third one is called as chunking, because every LLM has its own context window. So every LLM cannot afford large amount of data. So we need to divide large documents into small documents. This process is called as chunking. And fourth step is called as embedding. Means machine learning algorithms, deep learning algorithms or LLMs, they cannot understand text data. So we need to convert text data into high dimensional numerical vectors. Okay, now. So can I erase and discuss next topic, Sama? Otherwise, I'll create a new PPT and I'll add it here. Yeah. So the next step, fifth step, I will go here. Fifth step is called as The fifth step in RAG architecture is called as vector databases. Vector databases. So what is the purpose of vector databases? Here, whatever high dimensional numerical vectors are there, they will be stored. Vector databases are used to store high dimensional numerical vectors. High dimensional numerical vectors. Numerical vectors. Yeah. Okay, now. Then, for that, I will be teaching FIAS. Some people will use ChromaDB, Pinecone, and Viviet, and so on. Viviet, and so on. There are 7 to 8 vector databases are there. In today's class, I will be using FIAS vector store. Okay, now. And sixth step is called as, now we need to take query from user. Query from user. Then this query will also be doing embedding. Then query will also be stored in vector store. Stored in vector store. Then seventh step is called as now. Now our query will be searched in the vector store. Okay, now. Yeah. So now in this step, we are doing semantic search. Semantic search. I'll discuss how semantic search will be done with the help of distance measures, distance metrics. Like Euclidean distance or cosine similarity and so on. Yeah. Now we will be getting some relevant documents from the vector store. This step is called as retrieval. This step is called as retrieval. In RAG, R stands for retrieval kadama. Then eighth step is called as whatever. This is also called as context. Context for the query. Now the next step is called as augmentation. Augmentation means the context will be attached to query. People calling this one as a prompt. Yeah, this stage is called as, in RAG, A stands for augmentation, and ninth step is called as, now we are sending prompt to LLM. Now we are sending prompt to LLM. The last phase is called as LLM generates the content, generate response. This G stands for generation. This G stands for generation. Now, everyone, can you just put it here, ma? So the RAG architecture, according to me, I divided into 9 steps. First one is knowledge base. People calling this as data ingestion. Data ingestion. Ingestion. Yeah. Second step is called as parsing and pre-processing. Third step is called as chunking, dividing the data set into smaller documents. Fourth step is called as embedding. Here we will use Gemini embeddings or Gemini embeddings, or we can use OpenAI embeddings, or we can use Walama embeddings, or you can use another technique called sentence transformer. Sentence transformer. Sentence transformer supports various kinds of pre-trained models. So I will discuss all these things. Embeddings, I will use all these things in today's class. Then next step is called as whatever high dimensional vector store is there. This high dimensional in sense 384 vectors, 786, 1500 and 3000. Okay, now 3000 dimension vector store. Okay, now. So next one is called as store the high dimensional data in a vector store. Okay, now by using FIAS or ChromaDB and Pinecone. Now I will be using FIAS. Next one is, now we are taking query from user. Same query also be done embedding as well as vector store. Next step is called as semantic search. Now our query will be searched in the database. Whatever the documents. Now sometimes I will get top 3 documents, top 4 documents relevant to the query. This is called as relevant documents. People calling it as context for the query. And now while searching, we will use various kinds of distance metrics like Euclidean distance or cosine similarity. The next step is called as augmentation. Whatever the context we extracted, this context has to be added to query. This process is called as prompting. Now, this prompt we will be sending to LLM. Now, LLMs will do generation of the response. This is called as RAG. Okay, now everyone understood, Amma? So I will draw a beautiful diagram for this. Okay, now. So everyone, can you please look at here, Amma? Yeah, first one is called as documents, collection of documents. This is called as knowledge base KB. So the next step is called as parsing. Parsing means extracting text from the knowledge base. Third step is called as chunking, means dividing large documents into small documents. Fourth step is called as embedding, means converting text data into high dimensional numerical vectors. High dimensional numerical vectors. Yeah. And whatever the high dimensional numerical vectors are there, fifth step is called as storing the database in vector store. Then sixth step, now we will be taking query from user. So query will be doing embedding and query will be doing vectorization. Then here we will do semantic search using some distance metrics. So whatever the documents which are relevant for the query, they will get extracted. This process is called as retrieval. Okay, now. Then the process of relevant documents plus query is called as prompt. This step is called as augmentation. So once you get a prompt, this prompt will be given to LLM. Then LLMs will do generation of the data. Yeah, this is called as RAG architecture. Everyone, can you respond, Amma? Now, for loading the data, we may use PDF documents, text files, databases, or sometimes we'll use APIs. Next one is called as chunking. Anyway, I'll discuss in detail one by one, Amma. So next one is called as embedding, converting text data into numerical vectors. Sometimes I will use Gemini embeddings. Sometimes I will use sentence transformer. There is another pre-trained model is called as nomic embed test, which is available in Olama. And for storing vector store, I will be using either FIAS or Chroma database. This is called as indexing phase of the data. So here the most important point is called as chunking. How the chunking will be done? So there is a large document. A large document will be divided into small documents like this. While dividing the data into small documents, you should be take care for semantic. Okay, we should not lose semantic meaning. Semantic meaning. Sometimes what will happen? Some text will be in chunk 1, some text will be in chunk 2. So we will lose semantic meaning between the texts. So we should use a concept called as overlap. Sometimes they will use 50 characters overlap, 100 characters overlap. Then how chunking will be done? Look at here. I will be taking a small documents. So 0 to 100. Now 0 to 1000 means 1000 characters. Now I will be considering the overlap as 100 characters. My second chunk starts from 900. This is starting from 900, 1800 to this one, 1800 to 2800. So this is called as overlapping. So if we apply overlapping concept, then what will happen? If we apply overlapping with 50 characters or 100 characters, then it provides semantic meaning. We are not losing semantic meaning among the chunks, Yeah, it is a very important step. Okay, now. So in this example, I will be calling a function called as chunk test, where this is original text may be containing 5000 characters, and the maximum number of characters for every chunk I have considered as 1500 characters, and overlapping is maybe 100 and 150 characters. Okay, now. Yesterday I discussed this logic. Okay, now. Can you respond, Amma? So this process is called as chunking. Okay, now this is the most important part here. Chunking is the most important part. So once chunking is completed, then another most important point is called as embedding. Okay, now means embedding means computers do not understand text directly. So embedding is a conversion of text data into numerical representation. So that captures semantic meaning. So we should not lose the semantic meaning. So what will happen? Our text data will be converted into numbers. So where meaning will get preserved. For example, if I give a sentence called as machine learning is powerful, this sentence will be converted into high dimensional numerical data. This dimension can be decided by the embedding model. Who will decide this dimension? Sometimes the dimensions will be 384 vector, 786 vectors. But okay, but if I use Gemini embeddings, it will give up to 3000 characters also, 3000 columns width. Okay, now can you respond, Amma? Yeah. Now I hope everyone understood what is embedding. Yeah. Can you respond, Amma? So once we converted the data from numerical high dimensional vectors, then another most important point is semantic search. Okay, now so this consider these documents as our knowledge base. We converted the knowledge base into vector representation. At the same time, your query also will be converted into embeddings. Then your query will be matched with the knowledge base. So this is called as relevant documents. Relevant documents. Now, how your query will be matched with this document? For that purpose, we'll use distance measures. Today, I will discuss how this distance measures will be used, like Euclidean distance. Then cosine similarity. Okay, now. Then next one is called as vector databases. So vector databases is a databases designed to store for high dimensional vectors efficiently using similarity search. So people asking that why can't we use normal SQL instead of SQL searches by keywords, but in vector databases the searching will be done by the meaning. That's what I call it as semantic search. Semantic search. Yeah. Then in real-time applications in the vector store, we are using thousands or millions of vectors. So they will be range from 384 to and 1536 and 3084 also. Okay, now. So we need to find out most similar vectors very quickly. So you cannot use normal databases. So in order to overcome this problem, we are going to use high dimensional vector space, high dimensional vector stores, vector stores. Okay, now. So with your permission, can I continue, Ma? No. Now, for high dimensional vector stores, what we are doing, the vector databases stores embedding and indexing the data. Then it is used for fast similarity search between query and the document and returns matching criteria. For that, today I will be using FIAS vector store. Okay, now. Yeah. So people are asking, why can't we use normal databases? Because imagine if I have a 1 million vectors, each 768 dimensions. Okay. So in order to, if I use normal database, what will happen? It will become very slow. But if I use vector stores, every vector store have special kind of indexing structures like inverted file structure. It is also called as IVF method. Second one is hierarchical navigational small word, also called as HNSW. Next one is called as PQ, product quantization. So they will reduce the search time. Within seconds, you can access millions of records. Okay, na? Yeah. I hope everyone understood that. So why to RAG? Why to use RAG? Now, people are asking why we need RAG. Why RAG? The answer I will discuss in 2 minutes. So this is my normal LLM. Generally, for normal LLM, you give any query or a prompt. If you don't provide proper context, so whatever the responses which are coming, whatever the responses which will come, these responses produces Wrong answers. Wrong answer. This wrong answers, technically people call it as hallucinations. Hallucinations. So to reduce these hallucinations, first of all, what we will do, instead of communicating directly to LLM, first our query will be communicated with our own knowledge base. Okay, now that's what I so told here. Chonma, keep LLM's responses grounded facts. That is the reason number one. Always, whatever the responses, we will come with RAG, correct information, and reduces hallucination. And first of all, we can keep our data private, and we can answer any question to any document or any domain. This is the powerful RAG. Can you respond to me? So, when we should use RAG? ఎప్పుడు మనం RAG వాడాలి? Whenever we are working with private documents, like any kind of banking domain, insurance domain, healthcare domain, and it will be used mostly in medical domain, legal documents, research papers, and policy documents, and enterprise documents. In the hackathon, we have given all kinds of domains. In the hackathons, we have given all these kinds of domains. Okay, now. So with your permission, can I go, ma? Yeah. So I will go for implementation, how it will be done step by step. Then I'll go for steps. Yeah. So first of all, I will teach how embedding will be done. Everyone, can you please look at here, ma? I will be using Gemini embeddings for this purpose. So what is the meaning of embedding? Yeah, just give me 1 minute. I will take my slide. Yeah. So whenever you look at here, yeah. So if you observe carefully, what is embedding? Embedding converts text data into numerical vectors. Okay. So if I consider the string hello world, that will be stored in high dimensional vectors, high dimensional. Okay, now. So this high dimensional vectors captures semantic meaning of the text, not just words. So two sentences with similar meaning will be having two similar vectors, same similar vectors. You must remember this point. Okay, now. Can I go? Yeah. Now, let us work with a simple example. Yeah. I will be configuring my Gemini key. Just give me 1 minute. Just give me 1 minute. Yeah. I will be configuring my Gemini key. Then I will be using my Gemini model, Gemini 2.5 Flash. Now, in Gemini, there is a model called as Gemini embedding hyphen not one. This is a embedding model which is used for converting text data into numerical vectors. So every vector contains a 3000 plus high dimensional space. Now simply I have given a word called hello world. Then how this hello world will be converting? Look at here. Yeah, I have given a text word hello world. Then I'm calling generative AI object dot this object dot generative AI dot. I'm calling function called as embedding underscore content. Now my model name I have given as Gemini hyphen embedding underscore one. So I will be giving a prompt called as hello world. Then what kind of response I'm getting? Yes. Now, if you want to get the numerical vectors, you should call it is a dictionary. So a response of embedding. See what kind of data you are printing? Look at here. My input data is hello world and vector dimension is 3072. Very high dimensional vector it was. Then our hello world will be converted into this much large high dimensional vector. You can see only 5 values, but initially it will be having 3072 vector dimensions. Okay, now. Like every sentence, every document has to be converted into embeddings. I hope everyone understood how we used Gemini for conversion of text data into vector space. Okay, now high dimensional vector space. Embedding is it okay now? For that, what I used here in the problem, we used a model called as Gemini hyphen embedding hyphen not one. You can also use not four also. Both are available. Okay, now. So any questions if you have, you please ask me. I'll check it out. Any questions, Amma, regarding embedding? Yeah. Once embedding is completed, then I will discuss about how semantic search will be done. Okay, with a beautiful real kind of example. Now, I will be using same configuration with a Gemini 2.5 Flash. Yes. Now I have taken two tests here. The first test is the cat sat on the mat, and second test is the feline. PPT అయిపోయింది కదమ్మా, లేదు కదమ్మా, ఒకసారి జస్ట్ గివ్ మీ 1 minute అమ్మా, 1 minute please, 1 minute please, 1 minute please అమ్మా. Now, are you looking at my screen, Amma? Everyone, can you please tell me, are you looking at my screen? Can you respond, Amma? Everyone, can you please respond to me? Everyone, can you please check the screen? I think my team said that you are stuck at PPT. Okay, Nama? If you don't mind, I will teach this embeddings once again for 2 minutes, Amma. Because I'm teaching this with a real-time example, Amma. Can you please look at here? Everyone, can you please see my screen? Now screen is visible, Kadama? Yes. So, Mami, wait change. So, in 5 minutes back, my PPT got stuck, Kadama. I will be teaching embeddings once again. Yeah. So, what is the purpose of embedding? Earlier, what I said, Amma, in the PPT, the purpose of embeddings are used to convert text data into numerical vectors. Kadama. For that, in Gemini, it has provided a model. So look at here, Amma. My text hello world will be converted into high dimensional numerical vectors. Gemini embedding model supports very high dimensional 3072 high dimensional vector. So this high dimensional numerical vectors, why we should convert this data? Because these numbers captures semantic meaning of the text, not just the words. Okay, now. So two sentences with similar meaning will have similar vectors. Okay, now. Means, okay, now. Can you respond, Amma? Yeah. Now, let me demonstrate, Amma. Sure. Now, let me demonstrate how Gemini will use embeddings, Amma. So, this is my, let us import generative model. Then, let us configure the API key. Then, I'm invoking generative AI model with the help of Gemini 2.5 Flash, like yesterday. Now, I have considered a text hello world. Now, this hello world, we will be converting into high dimensional vector space. It will be done by using a model called as Gemini embedding not one. Okay, now. Then this text I will be sending here. See what will happen? What is the response? Response of embedding. So if you, this is a small dictionary, it's a key. Response of embeddings. Then I will be getting embedding. See, Emma? The length of the embedding will be 3072 high dimensional, and now I'm printing first 5 only. Actually, you will be having 3072 high dimensional. I'm printing first 5 numbers. Okay, now can you respond, Amma? Hello world will be, yeah, I will show you up to 100 numbers. See, Amma? Okay, now shall I run it, Amma? Here I'm showing first 5 things, so it is printing first 5 values only. Like this, it will get up to 3072 high dimensional vector space. I hope everyone clear, ma? This is called as embedding. Okay, now. Can I continue, ma? So shall I print first 100? Let me run. If tokens are available, I will get the response, ma. Chudandi. See, ma? I'm printing first 100 embeddings. See, ma? First 100. Like this, you will be having 3072 high dimensional number only for hello world. Okay, now this is called as embedding. Then next I will go for another very important topic is called as semantic search. Why is semantic search? First of all, we will be taking query kadama, query. Our query will be searched with high dimensional database. This is called as database. Kadama. Now our query will be searched with all documents. For that, we'll use semantic search. Semantic search. For doing semantic search, we will be using some distance metrics. Few distance metrics. Just give me 1 minute, Amma. 1 minute, please. Yeah. So for that, we will be using distance metrics such as cosine similarity or Euclidean distance or any distance, Euclidean distance and so on. Okay, now I will showcase these two in the class. Please listen, Amma. Yes. See here. Yeah. So I will be taking two sentences. The cat sat on the mat and the villain rested on the nut. These two are different sentences. See, Amma? First of all, I am converting them as embeddings. So after conversion of embeddings, I am not printing, but yes, both are having 3072 dimensions. Same thing I discussed earlier. Now, yeah, I will be calling cosine similarity between two vectors. I have two vectors. Okay, now everyone can respond now. So let us call cosine similarity function between these two documents, embedding document A and embedding document B. Okay, now we are calling a function cosine similarity between these two vectors. Okay, now numpy dot array of vector 1, numpy dot array of vector 2, because this 3072 dimensions is a numpy array. Then we are using cosine similarity formula. Okay, now see here, this is called as cosine similarity formula. So A matrix multiply B matrix divided by norm of A multiply norm of B. Always cosine similarity will give angle between two vectors. If the result is 1.0, the two sentences are same. If the distance is negative minus 1.0, opposite direction. Okay, now see, Emma? So what answer we got from the two sentences? Similarity between A and B is 0.76171. So it is nearly 1 kavati. They are similar meaning. Okay, now they are similar meanings. Okay, now. Now I will run same thing with please listen, Amma. I will do same thing with Euclidean distance. See, Amma, I have given two different sentences. What are they? Machine learning is subset of AI. Then ML is a part of AI. These two are very much similar, but third one is entirely different. Now I am asking cosine similarity. Now by looking at this, we can say that 1 and 2 are similar and 1 and 3 are different. Now I am asking a question. Please listen, Amma. I am asking cosine similarity between 0 and 1. So they are similar. See, the similarity is 0.8299. Okay, now. And third one, 0th documents and second document, they are not similar. So they are different. Okay, now. See, the values are will be between 0.53. They are not similar. Okay, now. So 1 and 2 are similar in meaning. This is called as semantic search. Then I will be also discussing Euclidean distance. But the rules for Euclidean distance is different. In Euclidean distance, when the two documents are similar, the value will be related to 0. It is exactly opposite to cosine similarity. Okay, now see here. Now I'm calling Euclidean distance between document 0 and document 1. See here, 1 and 2 having very similar because they are very close to 0. But 1 and 3, they are not similar. So their distance is nearly 1. Large values means very different. Okay, now can you respond, Amma? Yeah. So the meanings between machine learning and ML is a part of AI. Their distance is very small distance and their vectors are very close. Okay, now because sentences are similar, semantically similar, but between 1 and 3, machine learning and the weather, they are not same. So the larger the distance. The larger the distance means they are not same. Okay, now topics are unrelated. Now I will use the same technique in the RAG architecture. So with your permission, shall I enter into RAG, Amma? I will be waiting. Can you respond, Amma? Everyone. So in order to discuss about RAG, I am teaching everything, Amma. Please listen. Yeah. So in order to discuss about RAG, what are the things are very much required, Amma? Everyone. Yes. Now I have shown embedding case study. Then I have discussed about how semantic search will be done with the help of cosine similarity as well as Euclidean distance. Now it is the high time to enter into programming. Okay, now. So first few minutes I will discuss about what are the steps. What are the steps in the RAG? Then I will go for implementation. See, Emma? Step 1. Now, here in step 1, we need to do document loading is called as knowledge base, where we will take PDF documents, text documents, or any web pages. Second step is called as chunking, means long documents are split into smaller chunks and they will fit with LLM context window. So it will help preserve in meaning. Okay, now. Third step is called as embedding. Okay, now. So each chunk will be converted into numerical vectors. Now I discussed this topic. You can also use nomic embed test. Fourth step is called as vector store. Means all embeddings are stored in the vector store. Today I'm using FIOS to store the vector store. Okay, now. And fifth one is called as retrieval. Now, whenever a user asks a question, the question will be embedded into the vector and the system finds most similar document chunks. Okay, now this is called as retrieval. Okay, now. And finally, whatever the prompt we have, this prompt will be sent to LLM. Now LLM will do generation of the data. Okay, now either you can use Llama, you can use Gemini 2.5, or you can use GPT 4.1 or 4.2. You can use any LLM for your job. So with your permission, I will discuss about the components of RAG and I'll go to case study. If you want to implement components of RAG, first of all, you should know document loaders. Yes. Then you should do splitting the documents. Then we should do embedding. Then we should do vector store. Then retrieval. Then finally, LLM generation of the data. So I will be implementing all the steps with an example. Shall I go, Ma? Yeah. Yeah. So I will go for one small case study with RAG. Yeah. So I will be going a small example with RAG with the vector databases. Yeah. So with your permission, can I respond, Amma? Can I go? Everyone, can you please respond? The screen is okay for all of you? Everyone. I'm waiting for you. Any response from you? Yeah. Till now, I have discussed about theory and how it will be implemented. Now, I will be discussing one by one with a real-time program. Okay. Now, first of all, I'm importing from sentence underscore transformers, import sentence transformer. Okay. Now, so this sentence for transformer, I will use for embedding. Now, in hackathons, most of the people are complaining that hackathon, they are using Gemini models. Gemini models, they will give limited tokens. But the students are consuming all your tokens. So I am not using Gemini embeddings. Instead of Gemini embeddings, I will be using a pre-trained model called as all mini LM. Okay, V6. Okay, I will use this LLM. So this is a pre-trained model. To invoke this pre-trained model, I need a sentence transformer. Okay, now. Second one is to store vector store. I'm using FIOS. Okay, now. And you know this one, these two. So can I go? Yeah. So let me import the documents one by one. Yes. So let me import all the statements. Then now I'm configuring my Gemini API key. Then I'm configuring Gemini 2.5 Flash model as LLM. Then what I'm doing? Yeah, for doing embedding, I said I will be using sentence transformer where it will be calling all mini LM L6V2. It is a pre-trained model. Small pre-trained model. It is a small pre-trained model, especially used for embedding. But its capacity is 384 vector only. But Gemini embeddings will be 3072, very large. Okay, now, but we'll work with small amount of data right now. So You are creating an object of embedded. Yes. Now, embedded object is in our hand. Okay. Now, then I will be taking a small 4 documents, simple 4 documents. Our company policy states that all employees must complete security training annual. Like this, I have taken 4 documents. Okay. This is our knowledge base. Then what we are doing? This embedder dot encode of the document. Whatever the documents are there, we are storing, we are converting the data into numerical vectors. Look at here, ma. This is called as embedding. Means converting text data into numerical vectors. Numerical vectors. Okay, now see here you will be finding 4 documents. 1, 2, 3, 4. You have 4 documents. But every column is called as 384 high dimensional vector space, high dimensional numerical vector. Numerical vector. Is it okay now? So, first of all, I converted our text data into numerical vectors. Okay now. I hope everyone completed, ma? Everyone. Okay now. Then, once we converted embedding, then we should do, yeah. Now, I told you, kada, yeah. Here, documents dot embedding shape of 1. What the meaning of shape of 1 is columns. Shape of 0 means 4. Okay. Means every document will be having 384 vector space. Now, I will be using a technology, a vector store called Fayaz. Fayaz dot index flat L2. It is one semantic search. Flat search. Okay, now. So L2 means I'm using Euclidean distance. Now, whatever the dimension is there, whatever your dimension is there, you must tell your dimension to the Fayaz. Then what we are doing, whatever embeddings are there, look at here, whatever documents embeddings are there, these documents embeddings will be stored in the Fayaz. What is the meaning of this one? We are storing our high dimensional numerical vectors into the vector store, into the database like this. Okay, now storing the data as well as indexing. Okay, now this is what has happened. Indexing, yes, means our documents has been converted into vector store. Now it is our responsibility to take a query, and query also done embedding. See, yeah. Now I will be asking one question. Answer the question. First of all, before answering the question, let us take query. Yeah. So what I asked, how do I reset my password? Then what I am doing, answer the question. I'm calling a function called as answer the question. Go to here. Yes. Now you should also do embedding. Whatever the question you have taken, the question will also be embedding. Okay, now. Then this is my question. Okay, now. Now what I have to do? I know my knowledge base. I know the knowledge base that is called as index search. And I know my query. This is my query. This query now has to be searched in the database. See, index.search. I'm searching my query. I'm asking k equal to 2. Means I'm expecting top 2 documents. Top 2 documents. Okay, now. That's it. My job is done. This is called as retrieval. Now, whenever you retrieve the documents, you are getting 2 things. One is D stands for distances, and I stands for indexes of the documents. Okay, now I'm not considering these distances right now. I will discuss them later. And now, first of all, what I'm doing, I will take every index, and from that I am retrieving the retrieving documents. Okay, now this is called as retrieval. In RAG, you people find retrieval. This is retrieval. Okay, Kadama? Yeah. So once the retrieval completed, then what we are doing, all these documents, whatever documents we retrieved, they will be stored in a string, joining into a string. Then I'm asking a prompt. You are a helpful assistant. Answer the following documents. So I'm giving a context. I'm giving a question. This is called as prompt. Now, this prompt I'm sending to LLM, model.generate content of prompt. I will be getting response. Okay, now see what is my response? Yes, response will be stored in the answer. See what is the answer, Emma? What is the answer for my question? How do I reset my email password? So which document which is matched, Emma? Can you tell me? You can reset your company password via IT portal. You got the same answer. Is it okay, ma? Okay, now. Can you respond, ma? Yeah. So if you ask me one question, sir, can you discuss this D? Okay, now. This D stands for distances. Okay, now. This D stands for distances. See, I'm printing both distances also, indexes, as well as distances. Kadama. Chepandama. So here I asked, Chodanama, here I asked top 3 documents. So top 3 documents, then it is giving 3 indexes, index 2, index 0 and index 1. Okay, now clear? The index which is having smallest distance will be the answer. Okay, now clear for all of you? The second answer is, second document is the answer. This is 0th document, first document, second document. Okay, now this is what you should do in applications. Now in Hackathon, we will be providing uh, real-time problem statements. You should go to ChatGPT or you should go to Claude or Perplexity. You need to retrieve relevant documents for the domain. Then you should write a project. Okay, now shall I continue, ma? Yeah. Now I will work with another example. Yeah, I will work with another example with PDF. For that, I will be showing my documents. My document I'm showing. Please listen, ma. Yeah. Yeah. So I will be giving this document today. Please listen. Life cycle dot. Okay. Yeah. So I will work with my PDF document. So it has 8 life cycle steps: problem definition, data collection, data preparation, model selection, model training, model evaluation, optimization, and deployment. Now I will be asking, and I have taken 8 domains also: healthcare domain, finance domain, retail domain, manufacturing, and so on. Means 8 life cycle steps and 8 domains I have taken. Now I will be writing a small Python program, 5 hours program. See, import generate VI and import sentence transformer. Now we are going to collect the data from PDF file. So you need to take a parsing tool called PDF reader. Okay, now then configure the LLM and generate the model. And now here I'm using all many LM L6 V2. This is for embedded object. Okay, now. So first of all, I'm loading the data. I'm working with both Notepad documents as well as PDF documents in this example. See, Emma? I'm working both Notepad documents as well as PDF documents. See, everyone? Yeah. I will be taking lifecycle.pdf and I will be taking lifecycle.text file. In a single program, I'm working with both PDF files as well as text files. Okay, now. Please, Amma. I will be taking both PDF file as well as text file. So you need to write 2 functions. What are they? First function, load underscore text underscore file, is used to read the data from text file, and load underscore PDF underscore file. This teaching I discussed yesterday only. How to load the data with Notepad, how to load the data with PDF. Okay, Kadama. So first of all, I will start where to start the problem. Okay, now see, everyone. Yeah. So first of all, I will be taking files and I'm building indexing. So whenever you call a function called as build index, then what we are doing, see, Emma? Yeah, I will be going a function called as build index. Please, Emma. Yeah, build index. So build index, I'm sending the path of the location, and indexing I will be doing on Fayaz index, and I will be storing this in PKL file. For that, I'm using PKL, okay, PKL file, because whatever the model I'm creating, I'm storing the model in PKL file. Okay, now. Then, in order to store the chunks, I have taken list object. Now, see, I have written a for loop where we are collecting data from all text files, all PDF files by using load text file function and load PDF function. So, the total data we are storing in a variable called as the total data we are storing in a function called as all the chunks will be stored in list object. Okay, now all chunks dot extend means whatever the data we extracted from both CMA. So I'm calling a function called as chunk underscore text here. Chunk underscore text is a function. It will go here Every chunk size is 300 and overlapping is 50. So this function returns some chunks. Whatever chunks are there, they will be stored in the variable chunks. And finally, I'm storing local variable called as all chunks. So we retrieve the data and we are also done chunking. Then whatever chunks are there, they will be done embedding. Embedded dot encode of all chunks. Then embedding also done. Once embedding done, what we are doing? This embeddings, please listen. Whatever dimensions are there, CMA, whatever dimensions are there, yeah. So you are going to Fayaz dot index flat. You are adding the data. Okay, now all your embeddings are stored in the Fayaz index. Okay, now then your index will be writing to pickle file. Okay, now this is the functionality of build index. So once you build the index, then you are calling a function called as RAG query. In that, I am asking one question. Enter the what are the domains in machine learning? See, now I will shift my focus from RAG query to here, RAG query. Now I'm asking, give me top 3 documents. Now, so I'm calling function called as retrieval. Okay, now this is my retrieval. See, ma? Then what I'm doing? My embedded document, I am searching with query. Then I'm getting some documents. Now, whenever your query will be searched with the index, I will be getting distances as well as indexes. So from this indexes, I will be retrieving the documents. Now, whenever you call retrieve function, what it is doing? It is retrieving the relevant documents. Okay, now all the relevant documents we are doing a string. Then I'm creating a prompt. What I ask, answer the question using the following context. If the context is not enough, say you don't know. In the hackathon, sometimes we will give a prompt. If your documents does not have data, you should print you don't know. Then I'm giving context and I'm giving question. Okay. Then I'm sending this prompt to LLM model.generate content. I'm getting responses. See, CMA, I'm retrieving text as well as retrieve documents. Okay, now CMA, see question and documents. Now I'm printing question. Documents I'm not printing. Yo, see domains in machine learning. Is it printing, Amma? Is it extracting? No. I'm asked one more question. What is the life cycle steps in ML? See, Amma? It is saying these are the life cycle steps in ML. Okay, now. So this is what we want from you in the hackathon. So depending upon the problem, depending upon whatever the problem you will get out of 50, you need to find out the relevant documents and you need to create a RAG application and finally you should get proper answer from us, from the documents. This is the RAG. Now, some students are asking one question, sir, why we should go to RAG? What are the applications of RAG? Applications of RAG. Yeah. Means you can create your own question and answer system. Question and answer systems. Then you can create your own chatbots. You can create your own voice assistants. You can create any kind of summarizer applications. Any kind of NLP applications you can do. Okay, now that's the beauty of RAG. So I will wait for a few minutes, Amma. Any questions if you have, I will be happy to answer for you. Okay. Now it's your turn. Now I completed both theory part as well as implementation part. Now, if you have any questions, kindly post here. I will be happy to respond to you. Everyone, Amma? Any questions if you have in today's topic, I will be happy to respond. And please, Amma, I will wait for questions. Yeah, some students are asking. Yeah, very good question, Amma. Sir, can we get relevant data sets from Kaggle? Yes, sometimes we can get relevant data sets from Kaggle or you can do from LLM. LLMs also generates relevant documents, Amma. You can use ChatGPT, GPT, or you can use Claude also for the relevant documents or Perplexity. Okay, Kadama? Yeah. So this is the most important. Collection of relevant documents is more important. Okay, Nama? You can collect from Kaggle also. Kaggle user repositories also. Yes, this hackathon related to coding, Amma. This is related to both generative AI with LLM with RAG. This is purely coding, Amma. This is purely coding context. Okay, now. So once if you complete your project, you can keep your project as 3-2 project as well as 4-2 project, Amma. No need to do any project by you. Okay, now. Yes. Yeah. Finally, you should create a Streamlit application, Amma. Streamlit application. Finally, everyone must create Streamlit application to you. Okay, now. It is a rule, Amma. Okay, now. Can you respond, Amma? It is a very good question, Amma. Finally, we should create an application, Amma. Okay, now. Yes, very good question, Amma. Any more questions from anyone, Amma? Yes, finally, you should create a Streamlit application. So two industry people are coming, myself and one more person, Mr. Dr. Shomesh Rao Garu. He is a CTO in Yantra Technologies. Both will evaluate your applications and will give grades. Okay, now. Any more questions from anyone? And thank you very much for attending the session. And we look forward your attendance on Saturday Hackathon. And we'll meet once again. Thank you very much for attending, Amma. Shall we stop? Sai, any questions from anyone, Amma? Shall we stop, Amma? Yeah, thank you very much for attending all the people, Amma. Thank you very much.